Hi friends, welcome back. In this session, let us look at the system architecture of a computer. The computer architecture is the blueprint for how a computer is designed and built. It defines the structure and behavior of a computer system. It encompasses the hardware, software components, and communication between them. So we have different types of architectures possible. So the simplest one is a single processor architecture where we have one CPU, and this one CPU is connected to all the peripherals through the bus as discussed in the previous session. So we have bus arrangement where all the peripherals are interacting with the processor. Processor in turn consists of many elements like arithmetic logic unit, memory buffer unit, memory address unit, and many more such things. And also we'll have memory, which we usually call a cache memory. And because this memory is within the processor body, it is very well designed and will be working at the processor speed, whereas other memory, what we call, it's the primary memory, which is on the motherboard. The motherboard will not be working at the processor speed, will have many problems, so it will be working quite slower than the processor. So for example, if the processor is working at nanosecond speed, then the memory will be working at a microsecond speed, so somewhere 1,000 times slower, because the design of the processor, the environment in which a processor is designed is quite different from the environment where the motherboard is designed. So the speed of the motherboard will be quite low compared to the processor speed. So the primary memory will be working at a far slower compared to the processor. And since cache memory is built within the processor environment, it will be working at a almost processor speed. And we have I/O devices also connected to the bus. I/O devices through their device drivers are connected to the system via the bus. So that's how the single processor environment would look like. So we have one processor connected to its cache. Then we have bus, and to the bus main memory and the I/O devices are in turn connected. Then we have another environment where we call it as a multiprocessor environment, where we have multiple CPUs, and as we can see in the figure, so there are multiple processors, processor 1, 2, 3 up to N, and each processor in turn has its own cache memory, which we call L1 cache. So each one has its own cache memory, and along with that, there is one more memory which is provided to individual processors separately. So if processor 1 is working with some set of data or some process, then it will be stored in L2 cache. Same way, processor 2's L2 cache will be storing the process tools, data, and process details and all that, and so on. And what is common to all them will be stored in this common memory, which we call a shared memory. So when we are working with a large amount of processes, then we would like to make a parallel processing possible, and this is what we would like to work with. So this is possible because of the technology being enriched, and because the technology is improving, the size of the circuitry is getting reduced, the space required for building the circuit is reduced. But to ensure that the chip is usable by the humans, it should have some physical size. So to maintain that physical size, then we realize that a lot of the space is available free inside. So in order to make use of that, instead of leaving that space free, we can build new processors on the remaining space, and with that what we can have is on same chip we'll have multiple processors. So that's one aspect. On the other aspect was, with the time we have seen that the processor speed went on increasing from megahertz to gigahertz, but later we realized that at 3 gigahertz and above, the processor started becoming very hot and all that. So there were other problems associated with the chip designing. Beyond 3 gigahertz, it was not possible to go for increasing the speed. So we had to stop the speed to somewhere 3 gigahertz. But luckily, the size was shrinking, and hence more space was made available in the physical chip. And instead of having one CPU, we started thinking of multiple CPUs in that, which we started calling core. So at the beginning it was a single core. Now it went on to dual core, quad core, and so on. So it is just a N core chip we are talking with. So this is a N core chip we are talking, where there are N processors inside, and each processor is associated with its own L1 cache and its own L2 cache, and that is in turn connected through the bus to the outside world, like shared memory and other IO devices and all that. So the advantage of this is, when we are working with multiple processes, and we can allot one processor to each process, and all of them can be run parallelly. In case of single processor environment, even though we were trying to work on multi-process system, but only thing is that there was time sharing, and any given time only one process was working and all others were in sleep mode. But because they were working at a very high speed compared to human perception, we could feel that all are working parallelly, but in reality, they were not working in parallel. Only one process was active, all others were inactive in the single CPU environment. But now with multiprocessor environment, if there are n processors inside a chip, then we can allot one chip, one core for each process, and hence all n processors can be used parallelly to work with n processes. And this at the beginning, each process will be uh, got from the secondary memory to the primary memory, which in this case is the shared memory. And from the shared memory, each process gets into the cache memory. The cache memory is one which is working at a high speed. Therefore, the technological limitations are there that we cannot have any huge amount of memory as we wanted. So there is limitations for L2 cache, there is limitations for L1 cache, but shared memory which is there on the primary, so we can have a very huge amount of primary memory possible here, but the cache memories are of limited size. Therefore, uh, for each process, a part of the code will be taken into the L2 cache, part of the data is taken into L2 cache, and then it is supplied to the L1 cache, and processor is working with the L1 cache, whether it is process or data or the stack. So all these three components are put on the L1 cache, and whenever we are out of stock, then it is again taken from L2 cache, and if that is not available in L2 cache, then it will be taken from shared memory. So this all discussions we take in detail in memory management and all that. So what all happens here is we have multiple processors, multi-core processor to be precise. So we have a multi-core processor, and that is connected to all the outside world through the bus, and that's how a multi-processor environment works. Then the next version of that is the clustered systems where we are talking about node. So in the previous thing we said that there is a multiprocessor environment, and that is a multi-core processor. So we have each multi-core processor used as a node, and we have various nodes, and they are interconnected, and they in turn are having the common shared memory. So in each node you can see multiple CPUs and there is shared memory, and all these are again interconnected and they are made. So this talks something like a cloud environment and all that. Then the current trend is about the multi-core chips where we are talking about multiple cores. So we have a bus interface and then shared memory, and from that individual memory for each core. So there are multiple cores. So as we discussed in the previous few minutes back, so from the bus we have other off-chip components. So this whole thing in the violet band is the multi-core processor environment, and this the blue one, the light orange, and this red one, all these together are part of one processor, one chip, wherein we have shared memory, we have individual memory, and we have core processors. So this whole thing is one chip, and that is connected interface through the bus to the outside world. So that's something about the computer system architecture. So we have different types of systems like single processor, multiprocessor, and then clustered systems. And this multiprocessor is other way we can call it a multi-core system. So in this multi-core, we can run different process for using each core, or even a single process can be divided into different parts, and if they can be run parallelly, then we can run them in parallel so that we can speed up the process. So that's all for now. More details to follow. So keep watching, and please don't forget to like and subscribe and hit the like button. Thank you.